Okay, let me go ahead and start recording since I have some questions here in the room that you guys will all need to know about. And again, we're back on timeline. Now, the reality is we have this week, which is the 13th through the 17th, and then there's Thanksgiving week. And then there is the last week of class, which is going to be the 27th through December 1st. And then there is finals week. So we need to try and get everything that we wanted to get done sort of put into that week. Okay? So today I had already said was going to be homework number 4 questions, the Gaussian project overview. And then what I'm going to add in today is your exam 2 overview. Okay? So I really need to sort of stick to some schedules here. So this is for the 13th. For the 15th, on Wednesday, we are going to review conductors in terms of what we've seen already, plus some problem solving. And I will give out homework number 5 on Wednesday. Okay? 11:17 is going to be exam number 2 given. Okay, so I want to get that done so I have time to grade that over Thanksgiving break. Then that week of Thanksgiving, you guys will be working on homework number 5 and finishing up your projects. When we come back, the 27th of November, which is going to be a Monday, we're going to review dielectrics. And do a little bit of some problem solving with that. And you guys will get a homework number 6. In terms of due dates, homework number 5 will be due on that Monday. Then on the 29th, we will do a little bit of further work on dielectrics in terms of the chapter, so this might be some new content. And then on December 1st will be a final exam overview, where I tell you what to expect, what we will and will not have on the final exam. I wish we had gotten a little further, but you know, that's what that is. Okay. So I think I will probably give you until the December 4th, which would be a Monday. It's a Monday of finals week, so we don't meet. but we will have homework number 6 be due that day. Okay? Okay, so then comes the projects. I still have to look to see when our final exam is scheduled, but since we're a smaller class, we can do a little bit of TBA in terms of figuring out which time. I think classes that meet at 9 o'clock in the morning typically have a 7 a.m. final exam, which I believe that all 5 of you will agree to change it to a different time. We just have to figure out when we're going to change it to, okay? Because I don't think a 7 a.m. exam time is going to be good for anybody, okay? So you guys gave your sort of draft view of your presentations for the electric field. And I still need to get you sort of a little bit of a template PPT for you guys to finalize that. So I will get that today. It will be emailed out to you. And then what I would like is, let's see, we still have to also do the homework for redo will be due, and I would like for your recorded e-field project to be due. However, if you guys are having some technical issues, I might be able to do some remote as we're working on that, okay? The Gaussian Part A draft I will also have due on Monday of that week. And then the final version of the Gaussian we should be able to have by that. And we'll make your draft Gaussian Part B due there, and your final Gaussian due during by end of finals week, okay? So that kind of gives us some dates to be working on in terms of what we're doing here, okay? I need to get you the template PPT for the e-field project. And we'll talk a little bit about here, and I will be getting you an outline for the Gaussian. Probably by Wednesday, definitely by Friday, so that you can work on finishing that up. Okay? Does that sound reasonable? So the next due date is this homework number 4 redo. I got you your homework number 4s graded back last week. And you've got the key for that one posted already, so you were supposed to be working on that over the weekend. We'll have a little bit of a time here to answer some questions about that, but I want to go ahead and hit these other 2 things first, just to make sure that we got those recorded and that you've got that information. And I am going to start with the exam number 2 overview, okay? So one of the things on the exam, and I'm not sure what order these are going to be in because we'll have some conceptual things as well, but you will have a sort of problem number 1. Now, there might be some conceptual things on the front page before we hit problem number 1, because I like to, those are generally shorter things, so they just sort of fit well on the front page. Your first problem is going to be a numerical problem, okay? And you will get a source point and a field point in XYZ coordinates. And it's going to be a multi-step problem where you will have to find the separation and the separation unit vector. And then you will find the electric field at the field point. You will need to find the potential value at that field point. And then find the force on a test charge at that field point. Okay? So that will be one of the problems that you will have on the exam. Okay, then as a second problem, I had thought about putting a Gaussian on the exam, but because you guys are doing these Gaussian projects, and we have sort of limited amount of time on the exam, I'm not going to do a Gaussian on the exam. But we do have things like the divergence of the field and the, well, gradient of a potential. Now, probably what I'm going to have is that I should have listed these in the other order. Part A is where you find the electric field because it's minus the gradient of a potential function. Then part B is looking at the divergence of that field, and that's going to end up being related back to the charge density over epsilon naught. So I'm just going to change the order there. And these are going to be symbolic. So you will have a function with XYZ in it, and you'll have to take the gradient of that function. Now, I should be careful. I shouldn't necessarily say XYZ. I might give you one that's got one of the other symmetries.
we need to find out how to numeric value.
Right, okay. So you'll have a symbolic function for V, and you'll use that to find these values, okay? And then probably, now, just in case you get those things wrong, we'll start it with a separate problem. Which will have a density function. And I'm probably going to go ahead and give you a volume function. Okay? I have not decided on this one whether it will be XYZ, cylindrical, or spherical. Okay? That way, you will have to do things like find the charge enclosed within a particular volume. And I'm probably going to have you do this to find the potential function as well, because that's the integral of the dq over r and your 1 over 4 pi epsilon naught. Okay? And so that's the 1 over 4 pi epsilon naught rho d tau over r. As opposed to this one, the q enclosed is just going to be the integral of rho d tau. And you'll have to integrate it over the volume that's been given. Okay? So, and I'm going to do it for the potential function instead of the electric field function, because as we saw, when you have to integrate over the electric field function, you have to take into account the unit vectors, which can be yucky. And so let's just not do that on the exam. I made you do that on the homework, and then I made you redo the homework. So that should give you that. Okay? Then just a little bit of some conceptual questions type things. And I have to think a little bit about this. I haven't made a strict decision on this. But at a minimum, if I give you an E-field diagram, you tell me which charges are positive or negative. By the time you've done your project here, you should know that without a doubt. Okay? If I give you some potential contour lines and tell you if the charges are positive or negative, because it's kind of hard on those contour lines to see which ones are the dotted ones and which ones, etc. Then you draw a rough estimate for the field lines, because we know they have to go from positives to negatives, away from positives towards negatives, and they should be roughly perpendicular to the potential lines. Okay? So that is definitely a conceptual question, and that is definitely a conceptual question that you need to do. And I would have had some conductor conceptual questions, but we decided to go ahead and move conductors to the next one, so that will be on the final exam. I think that's probably going to be it. Okay? So in terms of preparing for this exam, you need to make sure you know how to do these things. I will again let you guys you can create a note sheet, okay? Now, I will, as a minimum, I will give you a, it will have the R vector, R magnitude, R hat for your XYZ coordinates, okay? Your base electric field and potentials for point charges, your base V for continuous charge distributions, which I also wrote up here in terms of your potential is equal to that. So I will have that one on there.
The ones you're mentioning right now will be on the test.
So I will have these as a note sheet. Now, what I may do is give you that sheet on Wednesday, and then you can add extra notes to it. Or if you have your extra notes on a sheet of paper, you can use that plus just the minimum sheet equation. Okay? And then the E equals the minus gradient of V, and the del dot E equals the rho over epsilon naught. The Q inside equals the integral from rho d tau. And probably I will also add on that equations, or I might put it on the exam, the geometry formulas. So in other words, what's d tau for the coordinate systems, and then if my gradient of V or my divergence of E is something that's not really easy to do in XYZ coordinates, then I would also give you the gradient and the del dot divergence formulas for those convergences, but probably only ones you need to use. Okay. So yeah, I'll go ahead and say that, so that since I'm not sure on this, we'll give other coordinates, grad and diverge if needed. Okay? So I might say, give you something that's cylindrically symmetric for your thing, and then give you the cylindrical ones, just to make that a little bit easier to work with. Okay? So that is the Exam 2 overview. And again, the Exam 2 will be given in class on Friday, the 17th. Okay? So I have to write that still. Okay. So having gone over that, the Gaussian project there's a part A and a part B. The part A is going to be the simple case with uniform charge density. And I made the decision that we're going to do this as you guys creating a PowerPoint. With the setup and the solution. And this is why you have to get me a draft first, okay? So, for example, on this, if you've got an equation for your draft version, you can write that equation by hand, take a picture of it, and put the picture into the PowerPoint. But then I will go through, because I don't have time to teach you, I've got a program that, I've got several different programs, where I can take that and format it into a typed equation with all the proper mathematical symbols. And then I will replace your image in your PowerPoint with that. Okay? I am not going to have you guys record these, though, this semester. Okay? I might have you guys set these up, and either I'll record them over the break, or we don't do those right away in my Physics 2 course, and so I might have you guys record those as part of a second semester. Okay? And then the part B is going to be the one where we have the non-uniform charge density. And this one will be a written solution. And the draft version with good handwriting, I will come in then and give you feedback on that solution in terms of any errors you might have, which hopefully we'll get those worked out before you turn in your draft. Where you might need to clarify your solution. Okay? And I'll also give you a feedback a little bit on your good handwriting. And then you guys will submit the final neat solution on paper. And then I'll do a high quality scan. Okay? Makes sense. Okay. So, again, I will get you a template. And we've talked about the general problem-solving solution, but I'll actually give you a PPT template there. But you guys will have to fill in everything there, okay? Project choices for Part A. Okay? We talked a little bit about this, and I don't know if you guys have kind of mentally thought of what you might like. There's going to be a little bit of a first come, first served on this as well, like we did with the other ones. Okay. Cylinder pipe with a surface charge, find field outside pipe. That will be one choice. And I should not say pipe. That is another choice. And because these two are so similar to each other, I don't think I want those as two separate ones. But probably what will happen is that whichever one you choose, I'll do the other one as another example. Okay? A sphere with a surface charge on the shell. Find field outside the shell, not field. Okay, so that's 4 choices so far. Okay,
Do you like the cube charge, surface charge? What would that be like?
so plane symmetry, large, flat, thick slab. No, I won't do this as one of the easy ones. Okay? So that plane symmetry is a possibility. Now, a cube with surface charge on the edges of the cube is not symmetric enough because the edges of the cube cause the field to go in weird ways. So you can't use Gauss's law for that. Okay? It would be an interesting one to do a integrate over the continuous distribution for, but it would be ugly. Interesting, but ugly. Okay? But the plane symmetry one you could do, but basically you're creating that little pillbox spanning the slab, and how much charge is inside the pillbox and how much has surface area on it. And so that's a possibility. Okay? So that is 7 possibilities. Again, because these are simple problems, and we've already going to have the geometry, and we've already talked about the template geometries and strategies for all of these, I don't think one is easier than any other one. Okay? So, pick.
Take number 2.
Okay.
Number 1.
You're going to do the pipe with the surface charge?
Yeah.
Okay.
Spheres.
Okay?
Scroll down. Number 3.
Okay, so that is a sphere with a surface charge on a shell. Okay. Okay, so those 2 ones are chosen, which means those of you who aren't here, I will be following up with you after I post this online, and you guys will have a choice of the other ones. Okay, so homework number 4, redo questions. Message me with images of your work or with questions referencing specific page section of my key. Okay? And just as a quick reminder here, we'll take a quick look at what these are. teaching, P401, homework, chapter 2. So the homework number 4 is this one. And so you've got a Gauss's law for a solid sphere with a charge proportional to the distance from the origin. Find the vector electric field for this potential using the gradient. Calculate the potential due to something at a specific point. Calculate the potential directly above the center of a charged disk with a uniform density or a non-uniform density. Find the total energy of the system, and then the conceptual conductors one, which we'll come back to when we hit class on Wednesday as well. Okay? And then my key for this has me going through for the Gauss's law and saying, okay, it's a sphere, so that's the area at a particular radius. Then for the charge enclosed, this was my original key where I still had K, but for the redo, we'll do C, just to make sure it makes sense and we don't have confusion between them. You will need to show the integral for that charge enclosed, and then put it together to find your electric field. For the electric field potential, we had an XYZ type potential, and so you had to find the gradient by taking all 3 derivatives of the entire potential in there, but at a specific point. So this was no, not at a specific point. This was the result of that derivative, and so that gave you the 3 components of the electric field, which then gives you a vector electric field. And then the potential at a particular point, and so you had to go through and find that. So you'll notice that some of the stuff that's going to be on the test is on here. And then this is a potential above a disk with a uniform, and so that's where we had to be, we used our cylindrical coordinates, and we had to use the integral tables on that. What I give you on the exam will not be something where you're going to have to look things up in integral tables, or if it does, I will give you like 3 choices of things you might have gotten, and so if you don't come up with those, you know you made a mistake. Okay? And then for the non-uniform distribution, it came up with something else that was in the integral table. Okay? And then the individual point charges arranged along the axis, we had to find the work, and so it was a matter of adding it up, and then it was just doing the math on that one. And then the sphere was, I went through, some of you guys just did it as a diagram, but at each surface, at the surface R, I had a positive at the surface, and so make sure you understand why that happens. Some students had said there would be no charge on A and B because it's a uncharged conductor, but the charge in the center causes it to have a density. The charge separates out, and so you get both of those things. And then at the different things inside the conductors, it was 0, and then outside, we had which way they were pointing and why. Okay? So that's a quick overview since you guys didn't have specific questions. Make sure you know how to do those things, and so redoing your homework number 4, as well as going back and looking at your redo on homework number 3, because that included finding the separations and finding the electric field at a specific value and finding the F and this density function part was also on homework 3. Okay? Okay. I will